Hello, my name is Ashley. I'm an incoming second year BME pre-med student, and I work in the Grossberg lab. Cardiovascular diseases are a leading cause of death in the United States. And this is a topic that I'm extremely passionate about because heart disease is something that I have had exposure to since I was a little girl. I watched my grandparents go through it, and I knew that when I got older, I wanted to be involved in work involving cardiology. And in order to do so, when I got to UCI, I joined the Grossberg lab. Now, cardiovascular diseases can be studied with a variety of models, like animal studies and patient observations, but where these models fall apart is that they can't isolate specific cellular mechanisms and functions. And with cardiovascular diseases being extremely complex and a variety of factors playing a role in them, having a model that can isolate these factors in a controlled manner can play a key role. And the heart on a chip does exactly this. The heart on a chip is a five-layer model through which we create heart muscles and assess how they form and how they beat. So out of the five layers, the layer that I focused on this summer was the elastic polymer layer. The elastic polymer layer is made of something called PDMS, which is a silicone substrate that mimics the flexible and soft nature of our muscles. And in order to fabricate this, we make a PDMS solution and coat it on glass. And in order for this to work, we need this layer to be even and free of air bubbles. But you can see through this picture, we were facing an issue because our layer had air bubbles and an uneven surface. The measurements across the glass had measurements starting from 5 all the way to almost 15, which is a range of 10, which shows an extremely uneven surface and is no good because with a surface like this, the cells won't adhere or stick, meaning they won't beat, and we can't experiment with this. We hypothesized that the reason why these uneven surfaces were occurring and there were air bubbles was because our PDMS solution had moisture in it. So to address this, we decided to place the PDMS solution in an oven for varying durations of time and on vacuum desiccators in hopes that all the moisture gets drained out of the solution before we coat it on our glass. And doing this got us good results. We had a more even layer and visibly we couldn't see any air bubbles anymore. And you can see the layers were more even because from the original range of 10, these range from 1 to 4, which is a significant improvement. And this meant better experimentation because with a more even layer and no air bubbles, the cells stuck to the model better and they beat better, which meant that we could experiment with them better and it was more reliable. While this project has been going in a positive direction, it isn't far from over. We're still working on getting the results to be consistent so that we can have a reliable and controlled model that can assess specific mechanisms of the heart and play a key role in advancing treatments for cardiovascular diseases. Thank you.